Hello everyone, my name is Alexandru Hang and welcome to Conf42. I will talk today about using the activity logs to predict user behavior and improve experience. So, what are we talking about? How can you use it to predict the user activity? I will try to predict the next activity of a user based on his previous activity logs and see how I can optimize the application. Why am I doing this? Well, because I want to optimize the applications to make sure that the server has resources and to make sure that the user has the best experience. How am I going to do it? By adding machine learning in the application. Machine learning that will analyze the activity logs. And some examples to see why you are here. That will be the most important part, but first a bit of theory. What's AI? What's machine learning? All those fancy names, what do they do for you? We know that activity logs are storing past actions of the users. Machine learning models are trained on historical data. I think you heard about machine learning, about AI in the past few months, years, maybe heard of AI. And you know that there are a lot of models such as neural networks, long short-term memory, transformers, all that that can be used to predict activities, to predict tasks, to predict numbers and sequences, and some other things. How machine learning model works? Like, let's say I want to build a system to classify an image and say if it's a cat or a dog. How? I give him 10,000 images of dogs and 10,000 images of cats. I'm going to ask you something right now. Which one's a cat, which one's a dog here? That's a stupid question. Of course, everybody knows which is a dog, which is a cat. Now comes a hard question. How do you know that? How do you know which is a cat and which is a dog? I'm just curious. I will give you 10 seconds to think a bit about it. The top one is a dog, obviously. But how do you know that? Did you took the image and analyze it? Does it have small eyes or big eyes? Does it have big teeth or small teeth? Does it have white skin, white fur, black fur? No, you didn't do that. Okay, come on. You just saw the image and say it's a dog. How do you know that? The answer is more tricky than you might think. Actually, you know it because you saw thousands of dogs in your life, okay? You know how a dog looks like. But you don't spend time to say how does it look like, how are its ears, how is its mouth, how is his nose or whatever. You don't do that. So you just know because your brain is trained to recognize which is which because you saw them. This is exactly how machine learning models work. They're using training data to build complex models inside the memory, and they are using those models in order to recognize patterns. This is what they're doing, and they're using them to predict, to classify some other things. So we gotta feed training data to the machine learning model. And then once the training is done, you'll see in a few seconds how training is done. We proceed to testing. We're gonna give him 100 images, other images of cats and dogs. How do we know which is which? The model should already know which is which. I'm going to ask him which is a cat, which is a dog. Let's say that out of 100 images, he managed to classify correctly 80 of them, and 20 are wrong. In that case, the accuracy is 80%. We compute the accuracy, and I'll say the accuracy is 80%. I'm happy. If not, back to training. Okay, so how do I use it right now? I have a few machine learning models to try. The first and most common one is a linear regression. The linear regression is not good for what I want here. I told you that I want to try to predict the next action that a user will take. The linear regression is good for predicting linear things. How? Well, it will take points, let's say the stock market, the value that the stock market had in the past 10 years, and to try to predict the next value of the stock market based on historic data. That's what the linear regression is doing. The decision tree is used to classify things. Well, it would be good for classification between cats and dogs, actually. But not really. But it would be good for other types of classifications, more simple ones. Let's say that you want to classify a text and say if it's English or French or other language. It will take a look, it will take a look at the verbs or the pronouns or some things, and it will try to classify it. Okay. The random forest is a more complex decision tree. It's a collection of decision trees. This is also used for classifications. We're not going to use it today. And here comes the tricky part, neural network. This is what we're going to use today. Neural networks are very good because they're adaptive. They can easily adapt to change, they can easily adapt to patterns, they can recognize images, they can do a lot of things, and they're very versatile. But they're a big black box. We don't really know from the outside how they're building the models and other things. So now I'm going to ask you a simple question. I asked you 2 slides ago, how did you know if that is a cat or a dog? And you said, I just know it. What if I tell you it's not really like that? Of course, for you, it's like that. I just know it's a dog, okay? But how do you know that? Here comes the tricky part. Our brain is structured like a neural network. Or actually, let me put this right. The neural network is structured like our brain. The neural network is built because the computer scientists which built it 20 years ago, or more than that, sorry, years ago, something like this, said, you know what? Let's try to mimic the human brain. How does the human brain work? We have the input layer. What is the input in your brain? Your senses. You have your eyes, your ears, you can touch things, you can feel things, whatever. This is the input. What's the output? You can do an action, you can move your hand, you can speak, you can close your eyes, you can do whatever you want. What's the hidden layer then? Well, that's actually, your brain is built out of neurons. This is where the term neural network comes from, the term neurons. Neurons are small cells inside your brain. You have billions or actually trillions of them. And those neurons are communicating between each other, forming super complex networks in which electrical currents are circulating. And they are communicating with each other millions of times per second to create your thoughts, your feelings, and other things. This is what neural networks are trying to replicate. But instead of using cells, because we can't build living cells, we're going to use functions. Some small objects, functions, classes, which have a function in them. It will be called an activation function. You'll see in a second what that means, because I won't explain right now. Those are functions that are communicating with each other, each one of them doing a specific task, and sharing the results. And then the final layer will filter this and give you a final result. So it's basically like a human brain. So why do we try to do this? As I told you, we want to be able to predict the next action of a user. But you're going to ask me, why do you want to do that? Good question. I want this because I want to personalize app experience. I want to optimize some common workflows. I want to identify which are the common workflows for each user and to optimize them. And I want to predict user actions to prepare for increased workloads on specific services. How do I do this? Let's give the setup. Let's say that you have a user activity logs. We need to predict in real time which tasks the user performs so that we can predict server usage per task. We'll build a small neural network to predict the next action for user. And some other alternatives can be a statistical approach, to not go into neural networks, to just go on statistics and say out of 100 users, 40 of them are going from home to newsfeed and from newsfeed to messages. Okay, that could work, but it will no longer be personalized. That will be some sort of a generic optimization. I want to do something different. I want to do personalized applications for each user. I want to be able to predict for each user the activity. So, how I'm going to do this? TensorFlow. Okay, I'm going to say what? Yeah. TensorFlow is a framework built by Google and maintained by them for building and running machine learning models. Why did I choose TensorFlow? Because it can be used to, it can use existing pre-trained models, it can retrain existing models, and can develop new machine learning models. It can quickly train new models, it can adapt to various models that exist, and can run either on server or in the browser. And this is the main thing why I chose TensorFlow, because I have some other alternatives too. But I want TensorFlow because they also provide us a browser solution, a JavaScript solution. So instead of putting more pressure on the server, I will try to transfer the workload on the front end here. Because to be something per user, as I told you, my task here is to do something per user to predict his workload. I want to see what the user will do, what actions he will take, and most importantly, how should the system react. If I know the next action for user, I can prefetch some data for it. I can predict what data he will need. I can predict the server load for that and some much other things. This is why I want TensorFlow, because I have a TensorFlow JS JavaScript alternative. And one more reason is that it's already used by hundreds of top companies. I won't even mention them. What I told you here, you might think that I'm repeating myself when I said I can use existing pre-trained models or I can retrain existing models. You say, isn't it the same? Not really. I can take an existing model already built by Google, by Amazon, by Meta, by Adobe, by whatever other huge company, and use it if it's free. They're usually published. Some of them are published on Hugging Face. It's one of the most common websites, Hugging Face. Or I can take that model and simply put it in TensorFlow and use it for my application. If you go on TensorFlow website, you can see that. They're already using hundreds of them. But let's say that I have a more specific use case. Let's say that Google built a model to identify cats and dogs. I'll tell you again. I'll give that example. Let's say that somebody did that. Somebody at a random university or at a random company built it. Okay. What am I doing with it? I'm running it, but I want something more specific. I want to be able to identify cats, dogs, and rabbits. I can't use that model because he doesn't know what a rabbit looks like. So how can I do that? I take that model and I retrain it. I retrain the model that they built and I give him 10,000 images of rabbits. And I hope that I'll be able to get the accuracy on all 3 classes. As it can identify cats, dogs, and rabbits, and so on. If that doesn't work, I'll develop my new model from scratch. I say, okay, leave aside what those guys built, and let me build my own model. So, I will try to show you right now something. I told you about the models. Regression, decision tree, random forest, neural network. What if I tell you that a neural network can be so adaptive it can do the things that the other ones can also do? Yeah, I'm serious. Linear regressions, I told you, are excellent for approximating things. Guess what? Neural network can also approximate some things. So, how am I going to do that? I'm going to build a basic regression example to approximate the next number in a function. Let's say I have a function, 2x minus 1, or something like this. But I won't tell the computer which is a function, and I'm going to approximate using a neural network. Obviously, the best example of the linear regression. But I'm trying to mimic a linear regression with a neural network. Exactly in a second, why am I telling you this? I'm going to import it as that. I'm going to define the model which is sequential, because the data is sequential. I know all the numbers, 0, 1, 2, 3, whatever. We're going to add hidden layers to the model. I told you earlier, this is basically the brain. The hidden layers are the brain of the model. This is what's thinking and taking decisions. Then I'm going to compile the model in a few seconds what those things, loss, optimize, and all those things mean. I'm going to define or import training data. This is the tricky part. Now I'm going to define the data. I'm saying in value minus 1, the one function is minus 3. In value 0, it's minus 1. In 1, it's 1. In 2, it's 3, and so on. So now the question will be, which is the function? It's pretty hard to find it out. But once the model is trained, she can easily predict it and say, okay, if in this point it's like this, okay. And then I'll ask him, what would be the value of the function in point 20? And the model will say, okay, based on the function, it will be whatever. It will be 35 or something like this. I don't know. I'm not good at math. I didn't compute it. I just shot you a random number. But this is how the model will work. You try to predict the value of the function to point 20. So why do I show you this? Because this stuff is similar to what I want with the user. Let's say that in this second, the user is at page home. Then he's at newsfeed. Then he's at messages. Then where will he be in the next 2 actions, or 3 actions, or 4 actions, or so on? So this is what we are going to do today, our next page prediction system. Let's say the user goes from home to newsfeed, to messages, to marketplace, to newsfeed, and where does he go next? I can do a statistical approach, or I can use the neural network to say, okay, predict me the next page in which the user will be. This is what I want to do right now. How? I'm going to gather required data from activity logs because I know what the user is doing. I told you, most of the applications already store it. And to transform the data for training, I'm going to initiate the model, train the model, and use it to predict. How? Let me give the practical example. Let's start writing code. This is why we came here, actually. Until now, this was all theory. Now let's start laying. So we have a lightweight Node.js application wrapped around the machine learning app. We have TensorFlow model running to predict the next user action, and will predict the actions. Then the predicted actions will be used to preload data or ensure server resources are available. So how do we get the data? Let's say that we just run it in memory right now. I didn't want to stress the network or something because no, I just have an array in network which will mimic the activity log. So how do we train and run the model? Well, this is pseudocode basically. Treat it as just pseudocode, and I'll give the actual code in the next 5 or 6 slides. First of all, we're going to transform the data. We're going to initiate the model, train the model, and then we're going to use it to predict the page. So how do we do each of those steps? How do we transform the data? We have the number of pages that the application has. Let's say 10 pages. Can I just pass to the model something like home, newsfeed, messages, shop, contacts? No, I can't. Why? Neural networks don't really work too okay with strings. They can't just handle words or strings. We have other models which are way too complex for us right now because we are not AI engineers, we're just software engineers right now. And there are more complex models which are handling strings. Now there are GPT, transformers, BERT, you might have heard of them on the news, but that's way too complicated for us right now. So what we're going to focus on right now is the neural network. So in order to give the neural network some data that it can process, we're going to transform all the data to numbers. And here we go. This is what we do here. By transforming it to numbers, we will just say page newsfeed is number 1, page home is number 2, page messages is number 3, and so on. And we're going to transform this to a vector, to a tensor. Basically what we're doing right now is called a one-hot encoding. That's what it is called. One-hot encoding. This is how TensorFlow accepts data. This is the best way to handle data. TensorFlow, the name tensor, means actually vector. It's some sort. The tensor is actually some sort of a vector. It's a more powerful vector using machine learning to pass data from one layer to another, but basically it's a wrap around a vector or an array. So now this is the most important one. This side and the next one are the ones where I came here. So this is how we initiate the model. We say it's a sequential model, I told you already, and we add layers to the model. What are those layers? I told you in the example we have neurons, neural network. So right now we have two layers of neurons. Both of them are dense layers because they have the neurons dense in each other. And this is the tricky part. First, we add the layer with the activation function rel. This activation rel. What is this rel? It's rectified linear unit. This is something that is used in the neural network in the internal layers. I can give you all the theory behind this. You should search online for activation functions. There are a lot of them, each one with its pros and cons. The most common ones are relu, gelu, and for the final layer, you usually use softmax. In the last layer, softmax. Softmax is the function that will take the data from the previous layer and try to put it in a class or in a result. We try to classify it, basically. And this is how we're going to obtain our final result. The first layer here, we try to act as the inner layer, which will calculate things and stuff like this. And the final layer with softmax, we try to basically take the results, make them linear, and use them to predict the next action. And we're going to take this and compile it. Now we'll compile the model and we can use it. You can see on the slide here what you can change here on your example. You can search online for all of this. How to change the activation, how to change the units, the optimizer, the loss, and the metrics. So what do I have right now? I have the model. But what is this model? This is the brain of the system. Consider that you just saw a newborn puppy, or a newborn cat, or a newborn animal. What can a newborn puppy do? Nothing. He can just breathe and eat. And that's all. Other than that, he doesn't know how to do anything. But he still has the brain in it. But the brain doesn't know how to do anything. It's same for puppies, for little cats, for kids, for humans, for everything, for everyone with the brain. So right now we built the brain of the system, but it's stupid. They don't know how to do anything. We need to teach him how to do stuff. So here comes the training part. We are training the model by giving him data using the fit function, model.fit. We're giving the user the activity log, the labels, which are the basic, which is the metrics, and we are going to see if it can predict them, if it can predict the next action of a user. So we're going to specify 100 epochs. So try to train your model 100 times. And the batch size is how many items you take in each batch for training. And now that we are at the finish, we have the model, we have the brain has been trained, you can actually use it to predict. We have the function model.predict, and we're going to give the user the current history and tell the model, hey, this is the current history, which is the next item that the user will access. Tell me. And what are we going to do with this result? Whatever you want. You can preload the next assets based on this. Let's say that you know that the user will now go to page messages. If you know that the next page is messages, you can easily do the request to the server while the app is idle and preload already all the data so that when the user clicks on messages, the app will load instantly because all the data is already there in the memory. Or we can use it to detect anomalies, user flows, or we can use it to predict the server workload or some other things. That was the tricky part, doing the actual prediction. If you want the full code, you can see it on my GitHub. I give you here also the source code. And you see how to initiate the model, how to navigate, how to process the data, how to train the model, how to predict, and how to print it. If you have any questions, please feel free to contact me on my email, my website, on the conference website, whatever you want. And feel free to ask questions. And thank you very much for attending Conf42. And have a nice day, everyone.